As we are nearing the end of the day and time moves more quickly toward the center of the vortex, we'll go ahead and start introducing ourselves while our slide emerges behind us. I'm Beth McCarthy, Program Director at Funding the Commons. I am by no means a subject matter expert on privacy by design, but I think it's a deeply important and timely topic, and I'm so inspired by what folks are building in the space about this. And back when I was in law school 10 years ago, I wrote this paper about that topic, and it's interesting to see how many of those things have come true and been really obvious thanks to the crypto space, and how many things are still exactly parked where they were back in 2013. So yeah, I'm really excited to share what some of these folks are building with y'all and kick it off with them. Please introduce yourself, and then we'll go into the questions.
Hi, I'm Nanak Nihal. I'm one of the co-founders of Holonym. Holonym builds human.tech, which is a suite of tools for digital rights via cryptography, one of which is the right to privacy. So we've been building privacy tools for about 3 years at Holonym, focusing on privacy preserving ID verification and how to use that for use cases like proof of personhood and civic infrastructure, voting, quadratic funding, etc.
Hi, everybody. I'm Florent. I'm a co-founder of Self. So basically, the current state of identity verification online is either you check for phone numbers and you don't really learn much about the person, or you ask people for a photo of their ID cards or passports, which right now doesn't matter at all anymore because you can just do deepfakes, or you try biometrics, but it's really hard for a few reasons. That's what WorldCoin is trying to do. And what we're doing is that we're taking identity documents like passports and ID cards and adding ZK on top of them so that people can do privacy-preserving proofs of identity. So for instance, they can prove that they're above 18 or above 21 or not in a sanctions list so they can do business in the US, for instance.
Sweet. I'm Aayush. I work mostly on ZK and FHE-related technology. My main work around ZK email involves taking an email we've received and then proving a redacted version of it is still valid. This is really helpful for identities that are not kind of your main passport or human identity. For instance, maybe you have a visa to a country, or you went to some event and you got an email receipt or something like that. So any kind of confirmation you get in your email, you can prove about yourself, which is also valuable for, like the previous panel said, proving certain data exports are valid or things like that, which is quite exciting. And then I also like thinking about FHE-related privacy tech around AI and deepfake provenance.
Hey, I'm Chris. I'm CTO at Lit Protocol. And in the context of common goods, I would describe Lit Protocol as a public utility for cryptography. It's like a threshold cryptography network that you can use to store secrets or money. We're all outsourcing trust all the time, and so you can do it to a decentralized platform instead of to a corporation or another person.
Cool. So to ground this discussion, I'll just run quickly through this foundational principles of privacy by design that I think are very useful for guiding how this cryptographic layer can enable more sharing, collaboration, safety, and security among the commons. So those which were laid out by Anne Cavoukian, the Information and Privacy Commissioner of Ontario, Canada, whatever that involves, but I think they're very pertinent. One, proactive, not reactive, preventative, not remedial. Privacy is the default, privacy embedded into design, full functionality that's positive sum and not zero sum, end-to-end security lifecycle protection, visibility and transparency, and a respect for user privacy. And I think obviously blockchain and cryptographically enabled technologies are uniquely positioned to make some of these things possible in a way that is not as feasible in centralized systems. So I would be really interested to hear from each of you how your work and the projects that are coming out of your companies right now are meeting some of these design principles.
Yeah, so at human.tech, we have an identity system called Human ID, which uses zero-knowledge proofs. So are people here familiar with ZK proofs, or should I explain? Raise your hand. Okay, cool. So zero knowledge proofs, which a lot of us work on, are proofs that let you prove facts about yourself without revealing who you are. So you can prove, for example, you're over 18. You can prove you're not on a sanctions list. You can prove you're in a certain allow list of jurisdictions. So this can be useful for compliance, for even entering a club without showing who you are, just showing you're over 21. It can be used for anything where you don't really trust the party that you're giving your identity to. And so zero knowledge proofs, they are not new. They started in the 80s, but they've only recently become efficient and somewhat easy as a developer to build. So we're seeing a really good era of ZK applications, of use cases of this privacy. And I think the easier it is for users and developers to use ZK, the easier it's going to be for these ZK technologies to be adopted, both in terms of proving time. So zero knowledge proofs are super slow. So there's like a lot of us and a lot of people here are working on making these practical for consumers, for allowing you to run them on your private devices.
Yeah, I think there's been a quite general problem since actually the beginnings of the internet, which is how do you know if someone is a real person and how do you know really anything about someone? And there's been a lot of attempts to create a kind of mapping between people and like addresses in crypto or people and accounts. And it's always very hard. You can try doing like webs of trust kind of systems, but they get polluted very fast if there's a few attackers that can get in the web of trust. And I think our main thesis is that actually there's a way to do it, and we can already do it if we accept to bootstrap on already existing identity systems, such as state systems. So for instance, passports, ID cards, Aadhaar, which is the Indian identity system. And if all of those governments don't think much about privacy when they create them, because when the government issues your passport, obviously they know everything about yourself. Then we can use ZK to basically build on top of them to add those privacy-preserving solutions, so that I can still kind of piggyback on what like the UN created when they decided the specifications for passports and my country is doing, while still allowing users to preserve their privacy. And this is what I think is exciting.
Yeah, and I think on the original principles you mentioned of like privacy existing by design and being built into the systems from day one, I think that's something we got just lucky for with stuff like passports and emails, is that, there just happens to be a digital signature we can make a proof of. But we're not going to be so lucky once, for instance, you have quantum computers that can break those signatures, or that can create fake ones or reverse engineer the private keys, because then these systems are going to become vulnerable. And so I think, and we saw similar patterns like from the beginning of the internet as well. Like TLS took super long to get adopted, and then TLS 1.3 they could only make tiny little changes because they knew that if they totally overhauled the protocol, they couldn't do anything new. And so I think people wouldn't adopt it. And so I think it is important to think like, okay, when we're releasing these systems, like we already see harms from things like deepfakes or whatever. When we're releasing new kinds of systems in the world, are we building robust mechanisms into them that allow privacy to exist in the future, such that we don't have to pull like some crazy high coordination massive update in the future, which is, as we've seen in the past, doesn't really happen. So I do think thinking about privacy concepts when you're designing non-privacy systems is super critical moving forward, but I feel like not enough people do that.
Yeah, when I think about privacy by design and those principles, I think about like first how hard it is to get sort of like normal people to care about privacy. And I think, when we talk about like bootstrapping from regular identities, right, not having to have people sign up to like a whole new system, I think that in order to get adoption for privacy, we have to make it as easy or better than using regular tools. And part of the thing that's so hard, I think, is that building privacy-preserving applications and infrastructure is so much harder than building like centralized non-privacy preserving infrastructure. And so like at Lit, we're really excited to try to make it so much easier for people to have private data and store it on the open web I like to describe what we make as like a public secret. It's like a service where anybody can use it to store secrets and outsource trust and things like that. And I think if we can make it super easy, where not only using a private app is as easy as a non-private app, but writing a private app is as easy as writing a non-private app, then we can just have a beautiful, flourishing future of privacy.
Yeah, I think this accessibility part is so important because I feel like that really ends up being the barrier to having a full stack. A full stack approach all the way from protocol to governance to an end user app. One question I have, one of y'all suggested this title with these acronyms. I was wondering if someone can jump in and explain those and what the difference is between them, because I know there's a lot of debate about, is privacy an information control system? Is it this kind of added veil that I think is maybe where some of this like lack of usability comes from, is this idea of something extra that's added. And I think highlighting the different approaches that are described by each of these acronyms could be a useful way to understand the conceptualization space and the different technical implementations. Would someone like to take that?
Sure. So yeah, that's a great question. So ZK, we've talked a little bit about ZK. It's where the user proves something about themselves. They have the private data and they do the computation of the proof. Now FHE is kind of like almost, I don't want to say the opposite approach, but it's where a server or maybe even a network can compute on the private data. To the server or the network never sees the data and they can compute on this. So this has different trust assumptions and computation assumptions. This is ideal for outsourcing your computation, whereas ZK cannot outsource it, but it's also a lot more efficient. FHE is still a little bit slow in its infancy. MPC is another interesting approach. MPC is multi-party computation, so the computation is not done by any single party, and actually nobody is seeing the data as they're computing over it. It's rather done by a network or by two or more parties. MPC has a lot of great advantages, but some of the disadvantages involve liveness. The network does have to be live. All parties have to be live. And also in some MPC setups, there can be risks of collusion, that if the nodes collude, they can decrypt the secret data. So if those can be, in setups where those are fixed, MPC can be very efficient and helpful.
Oh yeah, I would just jump into and add to help fix that collusion problem, you can use TEE, which is the other acronym. That's a trusted execution environment. And it's essentially like a hardware level verification of the software that's running on the computer, where the software can attest that it's running the correct code. Other nodes in the network can see that it's running the right code and only talk to it if it's actually running the right code.
Cool. So I guess one question that obviously is coming up a lot in this context and that each of y'all mentioned when we were talking through this are applications to AI. I think one that's really interesting to me is using this security layer to be able to draw deeper inferences and have access to data that can make more robust models without necessarily revealing everything about the data, and creating the security to contribute to a data of trust or a data pool. For example, maybe one or two of y'all wants to jump in with some AI applications that are really interesting right now.
Yeah, I think there's kind of two axes with AI. The first one is that AI makes it way more easy now to create a lot of synthetic data. So if you've ever back a few years ago, you looked at a tweet and you looked at the replies, you are basically sure everything was written by a human. Because they were language models, but they were just not that great. Now you look at a tweet and you really have no idea, and there's probably a few of those replies that are not written by a human. And it's kind of the same thing that happened for us for ID documents, right? It's they use, for instance, you want to open a bank account, they would ask you for a photo of your ID. Now there's just databases online of fake IDs. You can just generate them easily for whatever identity you want. And I think what's really interesting is that as AI makes it easier and easier to create a lot of data, then it's kind of what Vitalik talks about with digital hardness all the time. It's like it becomes more and more important to get those source of truth in the real world. Like the more I can create a lot of data, the more this mapping to, okay, what is actually happening in the real world and how can I connect it becomes important. And I think this is why like a lot of this identity verification and reliability issues come. And this is what we see with like X, for instance. They're trying to stop bots. They're trying to like make people pay to have a blue check mark, but it doesn't really work well. And so I think it makes a lot of sense for them now to explore those kind of solutions. Yeah, on the side of like having better models and training, I don't have that much expertise on this, but I feel like it's still very hard to use FHE. So it's one of the, sorry?
What does it stand for?
So FHE means fully homomorphic encryption. It's the only acronym that is not there, but that Nanak explains. And it's basically, it allows you to do training over private data without learning this data, but it's quite impractical right now. So I would suspect a lot of those like new applications will come out of like TE usage, for instance, rather than FHE. I don't know what you think about it.
Well, I'll just cut you off quickly because our time is coming to an end rapidly, and I want to hear Aayush's perspective because he's building some really cool stuff in this area.
Yeah, I mean, I think on the question, there's like the two aspects that Florent touched on, like the training and the inference. I think on training, okay, so on one side, like, okay, if synthetic data is so bad, how do you validate that it's real data? And one is like, okay, you just have all these digital signatures in the real world that come from some certain place. So if I have a digital signature that I can see, oh, hey, there was a hash that signature posted on chain in 2021. I know that that data must have existed at that point in time. And so, you know, you can get timestamps on, okay, this came pre-LLM. You can do things like authenticated came from some signed source. So I can say, hey, like, you know, if the Internet Archive signs all the data coming out of it, then I can just verify that signature. And now I know that this data came from some date from some source. And we don't have that exactly yet, but that would be quite useful for training. And then on the inference side, I think there's also a lot of interesting things where, okay, like now that we have this deepfake problem, okay, maybe with IDs, we're lucky that passports have signatures on them. We can do things like ZK proof of passport. But for general things like deepfakes, you know, how can you address that? There's some like early solutions like C2PA, but there's also more like next gen solutions like Proteus, where you're like really trying to make sure every single generated piece of image or text that's coming out of a frontier AI model is coming with a digital signature and is committed somewhere that anybody can authenticate. Hey, where did this come from? Is this a real thing? Or is OpenAI saying, oh yeah, we generated that 2 weeks ago? So I think just seeing more and more signatures, more and more provenance is going to be critical moving forward. And like, if we don't get that, we're just going to see the harms of fake AI content, deepfakes, bots, like start to take over our world.
Okay. Unfortunately, I have to shut down this discussion because time is running rapidly, but it's one that I think is so deeply important to understanding the common resource of the information that we share and yeah, how to have secure ways of organizing collectively in digital space. And there's so many different directions we can go in terms of cool stuff that you guys are working on, from helping people who are not able to have documentation in the digital space to, yeah, enabling some of these data trust models that are really cool. So really hope to continue this conversation at a future Funding the Commons. And thank you so much, guys.
Thank you.